thinking about when I'm writing my scheduling. You guys could just leave those out on the table and we'll put them away for you if you want.
Okay, please. Oh, thanks. I'll leave them on the table.
Alright, so this is the basic graph of what's happening in the kiln for everything I put into the kiln and take out of it. You can think of it as two halves. The first half is your ramp up, and that is addressing the type of mold you have in the kiln. And somewhat the glass, but generally speaking, this is all dictated by the shape and size of your mold. So everything I put in that is plaster and silica goes straight up to 400 degrees Fahrenheit, and it holds there for a period of time. That period of time is dictated by how many molds there are in the kiln, how thick those molds are, and possibly how sort of thick and thin they are. So those are all things that can stress the mold material. And what I'm doing at 400 degrees is removing the water, the actual water from the plaster. Now for our bowls, I'm going to hold it there for 4 hours. And that's the amount of time that I've been able to sort of cut this program down to make sure that we don't see any or minor cracking. Should hopefully not see any, but sometimes we have a few little fissures. And it's like kind of curing the molds. If you're at home in your own studio practice, you can hold a mirror or a piece of glass over the door of the kiln to see if there's any water vapor coming out. You see it kind of condense on that piece of glass. If you leave your molds out to dry for a week, this will be a much shorter amount of time. Maybe not at all. Then we're going to go up to 1100 degrees Fahrenheit over 3 hours for this mold. At 1100 degrees is going to burn out your chemical water. It's going to make your mold, kind of cure your mold, make it a little stronger. It's also the temperature at which bullseye starts to sag and slump a little. So it also can work as a bubble soak if you're fusing larger sheets of glass together. So it's a nice temperature for both of those reasons. And we're going to hold there for a half an hour. Then we're going to go, I have it abbreviated as AFAP in your notes, that's as fast as possible, to process temp, which for our bowls is 1350. For our tiles was 1400. So 1350 is going to give you a little bit of a different texture on the inside of your bowl. It also helps keep those edges from folding over on themselves. It's a little bit of a lower temperature. Still is going to be one piece of glass, but it's going to be a little more granular.
So since my tile's in there, it will still fire all right, even though it's not up to 14?
Yeah. It's still going to fuse all together.
Okay.
Yeah. We'll hold at 1350 for 20 minutes, and then we're going to go as fast as possible down to a annealing point, which is 900 degrees. So all of these times will vary depending on how many molds and the size and thickness of your molds. So this is all about adjusting for your mold. Everything that happens after process temperature is all about adjusting for your glass. So 900 degrees Fahrenheit is our annealing point. This is going to change for the type of glass that you have. So for Gaffer, it's like 840 or something like that. Something like somewhere in that area. The manufacturer, if they're making art glass, will tell you what these temperatures are. And then this is strain point. And I know the Gaffer tells me this as well, I just don't remember what it is off the top of my head. 700. Typically it's 15 to 20% below your annealing point. So we'll hold at 900 degrees for our stuff, it's only 2 hours. And then we're going to move from our annealing point to our strain point over 3 hours. Now, what I have been taught is that this move from annealing point to strain point is where your annealing actually happens. Then from this strain point to room temperature is what you're adjusting for thermal shock. Thermal shock is where your glass breaks because of sudden changes in temperature. Annealing is actually what's happening on the molecular level. I'm not a scientist. This is what I've heard. So 3 hours to strain point. Because our kilns are so well insulated, we're just going to shut them off after strain point, and it's going to be a slow enough cool to room temperature. It's less than 100 degrees an hour. So I have not had any problems with this annealing schedule for the thickness that we're working. questions about that so far? Okay. So I think for me it's helpful to think about adjusting for your mold, adjusting for your glass, and really everything I write follows this basic structure. Now Bullseye makes a thick slab annealing chart that you can print offline. I think it's a really long time. It is definitely a very safe schedule, and you could absolutely follow that schedule for anything you're doing with Bullseye. Another way that I formulate the annealing schedule for glass is following this formula, where x equals 1 hour for every 1/4 inch. So if I had a 1 inch piece of, and you decide on that dimension is your smallest dimension. So if it's a cube, if it's a rectangle that is let's say this is 3 inches by 1 inch by 2 inches, you would anneal for the smallest dimension. So you would consider this a 1 inch according to this formula. So that means that your x equals 4 hours. Everybody with me so far?
Yep.
So our x equals 4 hours. So you'll hold for 4 hours at annealing point. And then 2x is the amount of time that it takes you to move from annealing to strain point, which would be 8 hours. Half x is the amount of time you stay at strain point. 2 hours. 2x is another 8 hours down to room temperature. Strain point to room temp. So this is the formula that I use exclusively for annealing my glass when I'm film casting.
So the half X was how long you hold it at the
At strain point.
Okay.
And then another 2x from strain point to room temperature. If you had to hurry this up, I would start cutting here, strain point to room temperature. But again, can't guarantee that. So, but this is I have found this to be very safe for annealing anything that I have encountered in my own personal life.
Sometimes you read, talk about flash venting.
Yeah, crashing it.
Yeah.
So the idea of crashing your kiln has to do with avoiding devitrification, right? So devitrification is the changing of the structure of your glass. It starts to form a crystalline structure, and that crystalline structure is what gives you that cloudy appearance. So popular knowledge would have you open the door of your kiln to sort of speed up that movement, where you would be forming those crystals, and I think it's around 1350. That, I have not found devitrification to be a problem if it is a completely enclosed, it's a 3-dimensional lost wax casting. If it is something that, in pad de verre, again, it's not an issue for us. If it's something that is a wide open, flat casting with lots of surface area that's exposed in the kiln, that is where you could run the risk of forming devitrification, and that would be one instance where I would consider coming in to crash the kiln, to move from process temperature down to annealing point. For this specific application, you do not need to do that. All right.
Bye, everybody.
Bye, Mark.
Take care.
Thank you. Email me.